So first up, networking. Seriously, think of this as the digital foundation for literally everything else you're going to build. If you don't get this part right, nothing else matters. It's totally non-negotiable for building a secure and scalable solution. The absolute starting point, your ground zero, is understanding virtual private clouds or VPCs. The best way to think about a VPC is like building your own private, fenced-off slice of the internet inside Google's massive global network. And inside that fence, you make all the rules. You decide who gets in, what talks to what, and how all the traffic flows.
For the exam, they're going to want to see that you build things with a real strategy. So that means using custom mode VPCs, so you have total control and don't have IP addresses clashing with your on-prem networks. It means carving out subnets to create these secure zones, right? So your public-facing web servers are completely walled off from your critical back-end databases. And of course, it means using tools like Cloud Armor to fend off attacks at the edge, long before they get anywhere near your applications.
What's so great about this example is that it takes all that theory and makes it real. This isn't just about drawing boxes on a diagram. This is a defense-in-depth strategy. By splitting services into their own subnets and locking down the traffic between them, you limit the blast radius. So if one little part of your system gets compromised, it can't spread and take down the whole thing. Okay, so if you really want to level up your networking game, this is where you should focus. You need to get your hands dirty with hybrid networking. Understand the difference between a simple cloud VPN and a beefy, high-speed, dedicated interconnect. You should definitely dig into how Network Connectivity Center acts as this central hub for messy, complex, multi-cloud setups. And please, absolutely master the shared VPC model. I promise you, you'll see it in pretty much every large company. Awesome. Let's shift gears and talk about storage. This really builds right on top of our network foundation. Once you've got a secure network, you got to know how to properly store, secure, and manage all the data that's flowing through it. The big idea here is that data storage isn't just a set it and forget it kind of thing. It's all about intelligent management. What does that mean? It means automatically shuffling data to cheaper storage as it ages. It means making sure only the right people and the right applications can touch it. And it means being able to meet those really strict legal rules for how long you have to keep data around. So, what does this look like in practice? Well, you've got a few key decisions. First, location. Are you going to put your data in a single region for top speed or spread it across multiple regions for high availability? Next, and this is huge for the exam, is security through least privilege. You give an application only the exact permissions it needs to do its job and not a single permission more. And finally, you have to set up those automated backups for disaster recovery, making sure your data is always safe. This is such a perfect real-world example. So a media company has tons of old footage that nobody really watches anymore. Are they going to pay top dollar to store it? No way. They use an automated lifecycle rule to push it down to the ultra-cheap cold line storage tier. Then, for legal reasons, they slap a bucket lock on it to make sure that data can never be deleted. It's this awesome mix of saving money and managing risk. To really nail this down, you need some hands-on time. Go into the console and actually create a lifecycle rule on a cloud storage bucket. Make sure you can clearly explain when you'd use an online tool like Storage Transfer Service versus when you need to roll in a physical transfer appliance for those massive data migrations. And finally, you're going to want to get your head around how BigQuery handles data at just an insane petabyte scale.
All right, we've got our secure network, we've got our smart storage. Now we need the brains of the operation, the compute. Let's talk about how you'll be tested on setting up the systems that actually run your code.
For any modern cloud architect, compute is basically all about containers. And on the exam, you're going to have to make a big decision. Do you go with a simple, fully managed platform for a straightforward, stateless web app? Or do you need a powerful orchestration engine for a really complex, stateful application that needs to remember things? The real architectural decision almost always comes down to this trade-off right here. On one hand, you have Cloud Run. For simplicity and saving money, it's incredible. It can literally scale down to zero, so you're not paying a dime when no one's using it. You just give it a container. But for apps that need persistent storage, like a database running in a container, you need the power of GKE Autopilot. It handles all that stateful complexity for you, so you don't have to worry about managing servers. This quote just nails the kind of thinking you need to have. Got a public API where traffic is all over the place? That's a perfect job for Cloud Run and its scaled to zero magic. But what about a heavy-duty data processing job that needs its own dedicated storage and maybe a specific GPU? That's a classic case for GKE Autopilot, no question. Now, even though containers are the hot new thing, don't sleep on good old-fashioned virtual machines. You absolutely have to know about spot VMs for getting massive cost savings on batch jobs. You need to understand how to automate security patching across a huge fleet of VMs. And you have to know how Google Cloud VMware Engine lets companies just lift and shift their existing on-prem stuff into the cloud without a huge, painful rewrite. All right, let's get into the fun stuff. The advanced topics that really separate the good architects from the great ones. Section 2 fully expects you to know your way around provisioning and managing AI and machine learning solutions on Google Cloud.
You know, a huge part of being a great architect is knowing when not to build something from scratch. And the exam tests this directly. They'll give you a business problem and you have to decide, can I solve this in 5 minutes with a pre-trained API call? Or does this actually need a full-blown custom machine learning model built on the Vertex AI platform?
You should basically burn this table into your brain. For real. You need to be able to hear a request like, hey, we need to figure out if customers sound happy or angry on our support calls, and immediately know, okay, that's audio, which means I'm looking at the speech-to-text API. That mapping skill is so critical.
So beyond those easy-to-use APIs, you also need to get comfortable with the Vertex AI platform itself. You should study how its pipelines can automate that entire messy process, from preparing data to deploying a model. You need to understand how it plugs into BigQuery for raw data and into a feature store for those clean, reusable data points that make your models better. And you have to explore the model garden. It's like a catalog where you can find and deploy these incredibly powerful models, like Gemini, with just a couple of clicks.
And that's our tour of the core infrastructure in Section 2. We've hit the network foundation, the data storage, the compute engines, and that powerful AI layer sitting on top. So I'll leave you with a final question, the one you'll be answering as an architect. How would you design a system that uses all 4 of these pieces to be highly available, totally secure, and cost-effective? The answer to that's what's going to help you ace this exam. Good luck.